I'm going to talk about function transformations. All right? Function transformations refer to alterations to functions. For example, suppose we had a function, we'll call it f of x. Okay? There are various alterations we could make to that function. For example, we could make a new function equal to f of x plus some number, right? We could make a new function equal to f of x multiplied by some number. We could make a new function equal to f of x where we replace x with x minus some number. All right, so there's no shortage of various alterations we could make. So this is what people are referring to when they talk about function transformations. Now, for the rest of this video, I want to focus on how specific transformations affect the graphs of functions. Okay? So we really want to focus on graphs. Before I show you how specific transformations affect the graphs of functions, I want to encourage you to memorize a few graphs of functions that show up in a lot of situations. Okay? Do you know what the graph of y equal to 1 looks like? Do you know what the graph of y equal to x looks like? Or x squared? Or x cubed? Okay, those are some very common functions. Some other common functions, 1 over x, 1 over x squared, the square root of x, and the absolute value of x. Not only do these functions show up in lots of situations, but functions similar to these show up in lots of situations. If you memorize the graphs of these functions, I'll show you how to produce the graphs of similar functions. Okay? I'll show you how to produce the graphs of transformed versions of these functions. All right? So, let's continue. Let me draw some coordinate axes, and then we'll continue. Now, while I'm drawing, I would like you to think about what the graph of the x squared function looks like. That was one of the functions that I would encourage you to memorize the corresponding graph of. Okay? So I will make 3 copies of the graph that corresponds to the x squared function. So you may know that it is a parabola that looks like this. All right? It's a parabola that goes through the origin. All right, so now let's see how certain transformations affect the graph of x squared. Suppose I added 1 to the expression x squared. Now, one way to understand how graphs of functions will be affected is to make a table of x and y values. Okay, if you do that, you will see that the y values are increased by 1 relative to the old y values, what that's going to do is have the effect of raising the graph. All right? So it'll look something like this. All right? What about if I, instead of adding 1, what if I subtracted 2? All right? So again, make a table of corresponding x and y values, and what you will notice is that the new y values are decreased by 2. And that will have the effect of lowering the graph by 2 length units. Okay, so it's shifted down. Okay, now what about if instead of adding 1 to the right side like seen there, what if I added 2 like this? Okay, so I'm squaring not x, but x plus 2. Okay, again, make a table, compare the table of x and y values for the original x squared function and the new function. Okay, if you do, you will notice that the x values are shifted relative to the old x values, such that the following is the effect. The graph is going to be shifted to the left by 2. Now, notice that if you add 2, that the graph shifts in the negative x direction. Okay, sometimes it's easy to get the direction wrong. Okay, so it's the opposite of what you might think. Okay, if I did this transformation, if I ended up with x minus 1 squared, analyzing the table of values, you would see that that causes a shift to the right by 1. All right, so something like this. Now, it's perfectly understandable that you might be concerned that you will get the direction mixed up with respect to a certain transformation. That's why I keep emphasizing looking at tables. Okay, even if you make a table with just 1 or 2 points corresponding the points, the coordinates of 1 or 2 points, that's often enough to determine the direction of the shift. Okay, you don't have to make a big, huge table to avoid errors. Okay, and then what if we made these transformations? What if we stuck a negative sign in front of the expression? Okay, so what that will do is it'll change the sign of all the corresponding y values, and that will cause a horizontal reflection. Okay? Now, what if instead of sticking a minus sign on the outside, what if we did this? What if we squared minus x? All right? What that's going to do, instead of doing a horizontal reflection, it's going to do a vertical reflection. Now, because the black graph is symmetric with respect to the y-axis, the rotated version ends up being the same graph. So I'll just draw the green on top of the original graph, something like that. Okay. So there's 2 types of reflection. One is a horizontal reflection. One is a vertical reflection. All right, and the reflections on the left, the far left side, the far left coordinate axes, those are referred to as vertical shifts. The middle the middle graphs, those are referred to as horizontal shifts. Okay? Now let's look at the effects of a few more transformations. Okay, so as before, give me a bit to make some coordinate axes. And as before, I'm going to use the x squared function to analyze certain types of transformations. Let me make 2 copies of the corresponding graph with respect to x squared. And I'm just going to do a small portion of the graph of x squared. All right, so let's analyze the following transformation. 3x squared. So if you compared the tables of values, you would notice that the new values, the y values for 3x squared are all 3 times bigger than the corresponding original values. That would have the effect of, in a sense, stretching the graph in the vertical direction. Okay, if the coordinate plane was a rubber sheet, if you can imagine stretching it in the vertical direction, the graph would get pulled something like this. Okay, so whereas the old graph went through the point 1, 1, the new graph is going to go through the point 1, 3. All right. What about if we multiplied by 1/3 instead of 3? Okay, that's going to have the effect of making all the y values be 1/3 of the corresponding original values. Okay, so that's not going to stretch the coordinate plane in the vertical direction. It's going to compress it towards the origin. All right, so that's going to look something like this green graph. You see how it's kind of flattened? Okay, so if the original graph went through the point 1, 1 with coordinates 1, 1, this graph is going to go through the point with coordinates 1, 1/3. Okay, so these transformations are referred to as vertical. These types of transformations are either vertical stretches or vertical compressions. All right. Now, there's also horizontal stretches and horizontal compressions. Let's talk about those now. So the way you can get those is if you multiply. Well, let me show you. Okay, so what if the expression that we're squaring? What if we multiplied that expression by a constant? All right, so how is that going to affect the graph? This is going to have the effect of compressing the graph. If you think of, again, if the graph is a rubber sheet, compressing it horizontally towards the y-axis. All right, so let me draw a graph of that. So the original graph goes through the point 1, comma 1. Okay, now it's going to go through the point 1, comma 4. Okay. Now, what about if we analyze the following transformation, 1/2 x, that whole expression squared? All right. So that's going to be like stretching it, pulling it in the horizontal direction. So that's going to look something like this. The graph's going to look something like this. All right, so that graph's going to go through the point 1, comma 1/4. Okay, so we have vertical stretches and compressions, and we also have horizontal stretches and compressions. Now we've discussed several types of transformations. The next thing to learn, to discuss, is that you can apply multiple transformations at the same time. Let me show you an example of that. All right, so there's our graph of x squared. Now, what if we wanted to know what the graph of the following transformation looks like? Minus 4x squared plus 1. All right, can you see that there are multiple transformations happening to go from x squared to this function? All right, let's discuss those transformations. Well, the plus 1 has the effect of shifting the graph up, right? The negative on the left side has the effect of causing a horizontal reflection, okay? And the 4 has the effect of stretching the graph vertically. Okay, so you put all of that together, the vertical stretch, the horizontal reflection, and the vertical shift, and I hope you can see that you will get something like the following. Okay, so whereas the original graph went through 1, comma 1, all right, the new graph is going to have an x-intercept of 1/2. So it's going to go through the point 1/2, comma 0. Okay, and it's also going to have a y-intercept of 0, comma 1. It's not going to go through the origin anymore. All right. So once again, compare the corresponding tables of values to see to convince yourself that indeed this is the correct transformed graph. All right. Let me repeat that if you are ever lost with thinking about graphs of transformations, remember that you can just plug in a few points, okay? And often that's all it takes to clear up any confusion. Now, I'd like you to do some exercises. I'm going to show you what the graph of the absolute value of x looks like. Give me a minute to draw the graph, and then I'm going to ask you what the graphs of some transformations look like. So the graph of the absolute value of x looks like that. It has a V shape. All right. So what does the graph of this transformation look like? Now, do whatever you need to do to determine what the graph looks like. We want to move towards the day when you can just look at it and determine it in a few seconds without having to write anything down. Okay? So pause the video and figure that out any way you can right now. So I'll go ahead and show you what I would get. So the graph is, there's a vertical shift up by 1 length unit. So instead of going through the origin, the graph has a y-intercept of 1. Okay? Now, would you please tell me what the graph of this transformation looks like? The absolute value of x minus 3. So pause the video and do that now, please. Okay, so the graph is going to be shifted to the right by 3. So it's going to look something like this. Okay, and instead of going through the origin, it's going to have an x-intercept of 3. All right. Now, what about this transformation? 2 times the absolute value of x. Do that one now, please. In other words, find the graph of that one. Okay, so that is compared to the original graph, this graph, it's going to involve a vertical stretching. Okay, instead of going through the point 1, 1, it's going to go through the point 1, 2. All right, and so it'll look something like this. All right. Now, for our last example, I'd like you to determine the graph of a transformation that involves, a transformation made up of multiple simpler transformations. Okay, so what does the graph of this transformation look like? Minus the absolute value of the product of 2 and x, and then that whole value minus 1. So pause the video, make a table, do whatever you have to do to figure out the graph of that. All right, so I'll go ahead and do that one now. So there's a vertical shift down due to the minus 1. There's also a horizontal reflection due to the negative on the negation on the left side, the minus on the left side. There's also a horizontal compression due to the 2, okay, next to the x. So horizontal compression, horizontal reflection, vertical shift down. Okay, and as I said before, if you get a little overwhelmed or lost, simply plug in points. Okay, the original graph went through the point 1, 1. Okay? This graph has to go through the point 1 comma minus 3, right? Let's label the point 1 comma minus 3. Can you see how this is a very nice way to make some careful progress without making a mistake? The original point went through the origin. The original graph went through the origin. This transformation is going to have a y-intercept of minus 1. So let's label that point. Okay, so putting it all together, I hope you can see that the graph is going to look like this. All right.